Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry O-Levels multiple choice. Paper 11 from May-Jun 2021. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. A student has to measure 28.2 cm³ of aqueous sodium bromide. Which piece of apparatus should the student select? In part A, we have beaker, and beaker cannot be used for exact volume. It can only be used for approximate values of volume. So therefore A is incorrect. In part B, we have burette. Now the minimum division on burette is 0.1 cm³. So therefore we can measure 28.0 or 28.1 or 28.2 cm³. So this one could be the correct option. In part C, we have pipette. Now the volume of pipette is fixed. It is either 20 cm³ exact or it could be 25 cm³ exact. We cannot measure less volume than this. Therefore it is also incorrect. In part D, we have measuring cylinder. Now the smallest division on measuring cylinder is 1 cm³. So you can measure the volume up to 27 cm³ or 28 cm³, and so on. You cannot measure the exact volume of 28.2 cm³. So therefore this is also incorrect. Correct option is therefore part B. Question 2. Which property of a liquid ester can be used to check its purity before using as a food flavoring? Now purity of a liquid can be checked by its boiling point. You should always remember that pure substance always has fixed boiling point. Other properties like color, smell, and solubility, it does not show whether the substance is pure or impure. So the correct answer is part A. Question 3. Which sequence of procedures is used to separate a pure dry sample of hydrated copper 2 sulfate, which is CuSO4.5H2O, from a mixture containing hydrated copper 2 sulfate and calcium carbonate? Now we know that hydrated copper 2 sulfate is soluble in water, while calcium carbonate is insoluble substance. So first we are going to dissolve this mixture in water. Then the insoluble substance can be filtered out. So second process is filtration. Calcium carbonate will be filtrated, and then we have a solution of copper 2 sulfate which is hydrated. Third part will be crystallization. In crystallization, we are going to make crystals of pure copper 2 sulfate. So the sequence given in part B seems to be the correct option. In part C, we have distillation. Now distillation can be used to separate out two liquids while we have one insoluble substance. Therefore this cannot be used. Again in part D, we have fractional distillation, which can be used for different boiling liquids as we have insoluble substance. So therefore this cannot be used. Correct procedures is therefore given in part B. Question 4. J is an aqueous solution. On adding of aqueous sodium hydroxide to J, a green precipitate is formed. The resulting mixture is heated and no gas is formed. Aluminum foil is added to the warmed mixture. A gas is formed that turns damp red litmus paper blue. Which ions could be present in J? Now this question is from the identification of cations and anions. Among cations, we have iron +3, and iron plus 2. Now we are going to see which changes come for these two. We have iron plus 2, iron plus 3. Now first step is the addition of aqueous sodium hydroxide to J. So we are going to add aqueous sodium hydroxide. Now what happens with iron plus 2 is that it forms green precipitate. While iron plus 3 with sodium hydroxide aqueous, it forms reddish brown precipitate. As in the question it says a green precipitate is formed, so therefore it is not iron plus 3, it could be iron plus 2. Second part is we have ammonium ion and nitrate ions. When ammonium ions is present in aqueous sodium hydroxide, there is no reaction that takes place. Upon heating, what happens that ammonium ions, they form ammonia gas. For nitrates, when we add aqueous sodium hydroxide, aluminum foil along with little warming, then what happens is that ammonia gas is produced. And the test for ammonia gas is that as it is basic in nature, so therefore it turns moist red litmus paper to blue. Nitrate ions does not produce any gas upon addition of only sodium hydroxide. The gas is produced when aluminum foil is added along with warming. Therefore, the second ions present is nitrate, it is not ammonia. Correct answer is therefore part D. Question 5. Gas X has the following properties. First is that it is colorless, then it has no effect on either damp red or blue litmus papers. Third is no effect on lime water. Fourth is that it is flammable. What is gas X? In part A we have ammonia. Now ammonia is a colorless gas. So part 1 is correct for ammonia. Second is that ammonia can change red litmus paper to blue. So therefore second part is wrong for ammonia as ammonia is basic gas. We are going to move to part B. We have chlorine. Chlorine is not colorless. It is greenish yellow. So chlorine is also incorrect. Part C is hydrogen. Hydrogen is a colorless gas. So part 1 is true for hydrogen. It has no effect on red or blue litmus paper because it is neutral gas. So part 2 is also correct. Third is that it has no effect on lime water. This is also true for hydrogen. Fourth is that it is highly flammable gas. So all 4 options are correct for hydrogen. Part D is oxygen. Oxygen is colorless. It has no effect on litmus papers, no effect on lime water, but oxygen is not flammable. It only helps in burning. So all 4 options are correct for part C, which is hydrogen gas. Question 6. Which particle contains most electrons? Let's first find the atomic number from periodic table. For oxygen, the atomic number is 8. For neon, it is 10. For sodium, we have 11 protons. And for magnesium, we have 12. In neutral atom, the number of protons is equal to the number of electrons. So in neon, we have 10 protons. So there must be 10 electrons present. In positive ions, what happens is that electrons are lost. So as we had 12 electrons in neutral magnesium, we have lost 3 electrons to make it plus 3. So now 9 electrons are left. For negative ions, electrons are added. As we had 11 electrons in neutral sodium, we have minus 1 charge, so 1 electron is added. So now we have 12 electrons in Na minus. Similarly, in oxygen, 3 electrons are added, so 8 plus 3, we have 11 electrons. Greatest number of electrons are present in Na minus, so therefore answer is part C. Question 7. The diagrams show the structures of two solids. We have solid P and solid Q. This one is the structure of P and this is the structure of Q. Which row is correct? First we have to find whether the bonding is covalent, and second thing is the conduction of current. In P we can see that each atom is making 4 bonds with other 4 atoms, so it could be the structure of diamond. In diamond, what happens is that carbon makes 4 single covalent bonds with other carbon atoms. Similarly, each carbon makes 4 single covalent bonds with further carbon atoms. So no free electrons are present and it is bad conductor of current. So we have covalent bonding in P and there is no free electrons. Now moving towards Q, we have the structure of graphite. Graphite is also made up of carbon atoms, but the difference is that in graphite, one carbon makes 3 single covalent bonds with other 3 carbon atoms. And between the 2 layers of carbons, there are weak intermolecular forces of attraction. These are not bonds. Covalent bonding is present among carbon to carbon atoms. So we have covalent bonds, and as one carbon is making 3 bonds and we have 1 electron left which is not involved in bonding, so therefore it is a good conductor of current. So in both P and Q we have covalent bonding and the conductor is only Q. Correct answer is therefore part D. Question 8. What is a covalent bond? In covalent bonding, we actually have sharing of electrons among nonmetals. Part A, a pair of electrons shared by 2 non-metallic atoms. This one is correct. For example, we have hydrogen. Hydrogen is a non-metal. Hydrogen shares 1 electron with other hydrogen atom to make single covalent bond. So we have a pair of electrons which is shared by 2 non-metallic atoms. Part B, electrons being shared by a lattice of positively charged ions. This is incorrect. We do not have any lattice present in covalent bond. Part C, elements losing electrons to achieve a noble gas structure. This is the formation of positive ions, because positive ions are formed by loss of electrons and these ions are present in ionic bonding. Part D, we have oppositely charged particles strongly attracted to each other. Again, this is the positive and negative ions that are present in ionic bonding. This is not covalent bond. Correct answer is therefore part A. Question 9. The empirical formula of compound X is CH2 and the relative molecular mass, which is MR of X, is 70. What is the molecular formula of X? To find molecular formula, we can use this. Molecular formula is equal to N multiplied by empirical formula. As empirical formula is given in the question, so we have to find the value of N. N is a number and it can be found by dividing molecular mass or molecular formula mass which is also known as MR divided by empirical formula mass. Molecular formula mass is given in question, it is 70. So we can put the values. N is equal to 70 divided by empirical formula mass. In empirical formula we have 1 carbon which is equal to 12, 2 hydrogen atoms which equals 2 and total is 14. So N comes equal to 5. Now we can put this value of N, 5 into empirical formula which is CH2. So now when carbon is multiplied by 5, it becomes 5 carbon atoms, and hydrogen multiplied by 5 becomes 10 hydrogen atoms. Correct answer is therefore part C. Question 10. A chemist wants to make calcium nitrate. They start with 8 grams of pure calcium oxide and an excess of dilute nitric acid. They produce 12.65 grams of pure dry anhydrous calcium nitrate crystals. What is the percentage yield of calcium nitrate? We have relative atomic masses that are given. For calcium it is 40, for nitrogen it is 14, for hydrogen 1 and oxygen is 16. The formula of percentage yield is equal to actual yield, or we can also say experimental yield, and it is always given in the question. This question they have given this as the yield, so therefore this one is the actual yield divided by theoretical yield. Now theoretical yield can be found out by balanced chemical equation multiplied by 100. Let's first write the balanced equation for reaction of calcium oxide with dilute nitric acid. We have calcium oxide, nitric acid. It forms calcium nitrate along with H2O. Now we can balance this equation. We have 2 nitrates on the product side, so we can write 2 with HNO3. Now rest of the equation is balanced. We have 1 calcium and 1 calcium. We have 2 hydrogen atoms on the reactant side, 2 hydrogen atoms on the product side. 7 oxygens on the reactant side, 7 oxygens on the product side. In the question they have given that dilute nitric acid is in excess. So therefore the product always depends on the limiting reagent. So calcium oxide is the one that is limiting. As we have 1 moles of calcium oxide, it forms 1 mole of calcium nitrate according to balanced equation. But in the question they haven't given number of moles, they have given mass of calcium oxide and mass of calcium nitrate crystals, so we can convert this mass into moles. The formula is number of moles is equal to mass in grams divided by molecular mass. So mass in grams is given, it is 8. MR for calcium oxide can be found out. We have 40 for calcium, 16 for oxygen, so it is 56. So 8 divided by 56, it comes equal to 0.1428 moles. So if 1 mole of calcium oxide forms 1 mole of calcium nitrate, so therefore 0.1428 moles of calcium oxide will form similar moles of calcium nitrate, as the ratio is 1 to 1. Now we have the moles of product that is formed. We can now convert this number of moles into mass in grams. Formula used is mass in grams is equal to number of moles into molecular mass. Number of moles is 0.1428. Let's find the molecular mass of calcium nitrate. We have 1 calcium, 40, 2 nitrogen atoms, 28, 6 oxygen atoms are present. So 16 into 6 becomes 96. We can add them together, it forms 164. So 0.1428 into 164. Now we have the mass in grams for calcium nitrate. It is 23.42 grams. Now this yield is calculated using the balanced equation, so therefore this one is theoretical yield. Now let's find the percentage yield. Actual yield was given in the question. It was 12.65 grams. Theoretical yield we have just calculated, 23.42 grams into 100. Grams cancels out with grams. So the percentage is 54%. Correct option is therefore part A. Question 11. The relative formula masses of 4 compounds are given. A student has a 1 gram sample of each compound, which sample contains the highest number of moles of oxygen atoms. Mass in grams is given. Now we can find the number of moles of each compound using the formula. Number of moles is equal to mass in grams divided by molecular mass. Molecular mass is a given. So for aluminum oxide, we can find the number of moles. It will be equal to 1 divided by 102. And it comes equal to 0.0098 moles. Similarly, 1 divided by 80 for copper oxide. Number of moles is equal to 0.0125 moles. We can do this for the next two. 1 divided by 98. 0.0102 moles. And last one is nitric acid. 0.0159 moles. Now we can find the moles of oxygen atoms in each of the compound. First one is aluminum oxide and oxygen. In 1 mole of aluminum oxide, we have 3 moles of oxygen atoms. So we can write 1 mole for this, 3 moles for oxygen. This is because in formula we have 3 oxygen atoms and 2 aluminum atoms. So in 1 mole of aluminum oxide, we have 2 moles of aluminum atoms and 3 moles of oxygen atoms. If 1 mole of aluminum oxide has 3 moles of oxygen, then 0.0098 moles of aluminum oxide will have X moles of oxygen atoms. By cross multiplying, we can find the value of X. So it is 0.0294 moles. This is the moles of oxygen atom present in 1 gram of aluminum oxide. Similarly, for copper oxide, we can write the ratio. One mole of copper oxide contains 1 mole of oxygen. As in the formula, we have 1 atom of oxygen. So for 0.0125 moles of copper oxide, we have X moles of oxygen. By cross multiplying, the number of moles of oxygen atoms is also similar. Similarly for sulfuric acid, in the formula we have 4 oxygen atoms, so therefore 1 mole of sulfuric acid has 4 moles of oxygen atoms. So 0.0102 will be X, cross multiplying, it is equal to 0.0408 moles. Now the last one is nitric acid. One mole of nitric acid has 3 moles of oxygen atoms. So 0.0159 moles would have X moles. It comes equal to 0.0476 moles. Among these we can see that highest value is this one. Therefore correct option is D. Question 12. How many elements combine to form the compound ammonium sulfate? In ammonium sulfate we have ammonium ions. Ammonium is NH4 positive and sulfate is SO4 negative 2. So when forming formula it will become NH4 to SO4. So we have nitrogen, we have hydrogen, sulfur and oxygen. 4 different elements combine to form ammonium sulfate. Correct option is therefore B. Question 13. An aqueous mixture of copper 2 nitrate and silver nitrate is electrolyzed with pure copper electrodes. Which half equation correctly describes the change occurring at the anode? Now you should always remember that anode always dissolves in solution of its own ions. Similar thing has happened in this experiment. We have copper electrodes. Anode is of copper, cathode is also of copper, and the solution is also of copper ions. We have copper nitrate, which is aqueous. So ions are copper plus 2 and NO3 minus 1. Similarly, we have another solution of silver nitrate. So we have silver ions and nitrate ions. In electrolysis, we have battery that is attached. So copper metal will dissolve in its own solution. This is copper solid. It will dissolve to form copper plus 2 along with the loss of 2 electrons. We can see that this one is the correct equation. In this equation, copper ions are being deposited on anode, which is not possible because copper ions can be deposited on cathode. Copper ions will move towards cathode. This is the cathode. This one is anode. So copper ions will gain electron from cathode and then they are deposited on the surface of cathode. The equation will be the reverse of this one. In part C, we have silver ions. Now at anode, silver ions are not dissolved. And this one is also wrong. You can also remember that at anode always oxidation takes place. So oxidation is the loss of electron, it is not the gain. Correct answer is therefore part A. Question 14. The diagram shows the electrolysis of concentrated and dilute aqueous sodium chloride using inert electrodes. Gases are produced and collected in each of the test tubes. We have W, X, Y, and Z, which are the test tubes. Which statements are correct? We have concentrated aqueous sodium chloride in this one. We have dilute aqueous sodium chloride in this one. This one is the positive terminal of battery and this one is the negative terminal. So positive terminal connects to the anode while negative terminal connects with the cathode. If this is anode, then this will become cathode. If this is cathode, then this will become anode. We have concentrated aqueous sodium chloride, so we can write the ions present. We have Na positive, Cl negative. We also have water, so therefore H positive and OH negative are also present. As the solution is concentrated, so the number of negative chloride ions will be quite high as compared to OH negative. First reaction is at anode and second at cathode. You should remember red cat, which means reduction always occurs at cathode, so oxidation always occurs at anode. Anions will move towards anode. We have Cl negative and OH negative. Due to the high concentration of Cl negative ions, Cl will be discharged first on the anode. And we have loss of electrons. Chloride ions will lose electron to form chlorine gas. We can balance the equation. Second is the reaction at cathode, which is reduction. So cations will move towards cathode. We have H positive and Na positive. Among these two, according to discharge series, H positive ions are discharged easily as compared to Na positive. So it will gain electrons to form hydrogen gas. We can balance the equation. 2 hydrogen ions make 1 mole of H2 gas. Moving towards next one, we have dilute aqueous sodium chloride. Again, the ions present are same. We have Na positive, Cl negative, H positive and OH negative. As this is dilute aqueous sodium chloride, so now chloride ions have less concentration as compared to the concentrated one. Again, anions will move towards anode among Cl negative and OH negative. OH negative are discharged first. It will form water, oxygen along with the loss of 4 electrons. Now we can balance this equation by writing 4 with OH, 2 with H2O. This is the reaction at anode and oxygen is produced. Second reaction is reduction at cathode. Cations will move towards cathode. The reaction will be similar to this one. H positive ions are preferred in discharge as compared to Na positive, so H positive will gain electrons to form hydrogen gas. Another important thing is that we have loss of 4 electrons and in this one we have gain of 2 electrons. So now we can balance the electrons lost and electrons gained by multiplying this equation with 2. So it will become 4H positive plus 4 electrons forms 2 moles of H2. So we have 2 moles of hydrogen produced at Z. Let's move towards option. Statement 1. Approximately equal volumes of gas are produced and collected in test tubes W and X. In X we have 1 mole of hydrogen gas that is being produced, and in W we have 1 mole of chlorine, so therefore this is true as both are 1 mole. Part 2. Approximately equal volumes of gas are produced and collected in test tubes Y and Z. In Y we have 1 mole of oxygen being formed by the loss of 4 electrons. In Z we have 2 moles of hydrogen being formed by the gain of 4 electrons. So therefore they are not equal. Part 3. 3 different gases are produced in the experiment. we can see we have chlorine gas that is formed, hydrogen gas is being formed, and oxygen gas is also formed. So therefore statement 3 is correct. As 1 and 3 are correct, so therefore answer is D. Question 15. Which positive ions are present in aqueous copper 2 sulfate? We have aqueous copper 2 sulfate, which means we have water. In water, H plus and OH negative are present. In copper 2 sulfate, we have copper plus 2 ions that are present, and sulfate ions are also present. Now the positive ions are H positive and copper plus 2. Therefore, correct option is B. Question 16. These statements refer to hydrogen and its use as a fuel. First one is that both water and hydrocarbons can be used as a source of hydrogen. This is correct statement because water, when electrolyzed, it can be converted back into hydrogen gas and oxygen gas. So hydrogen can be formed from electrolysis of water. Second is hydrocarbons. By cracking of hydrocarbons, long chains can be converted into short chains along with the production of hydrogen gas. So statement 1 is correct. Option 2. In a fuel cell, hydrogen reacts with oxygen to generate electricity. This is also a correct statement because in fuel cell hydrogen is present, which combusts in the presence of oxygen to form water, and this reaction can be used to generate electric current. Option 3. The reaction taking place in fuel cell is a redox reaction. This is also a true statement. We can see the reactions taking place. At cathode, what happens is that oxygen gas moves towards cathode, it gains electrons along with water molecules to form hydroxide ions. These hydroxide ions are then removed by hydrogen gas. By this reaction, we have hydrogen that reacts with hydroxide to form water along with the loss of electrons. So now we have gain of electrons, which is reduction, and loss of electrons, which is oxidation. So therefore this is a redox reaction. Now second option is also obvious from this equation. We can see that hydrogen gas forms electrons, so therefore it can be used to generate electricity. As all three options are correct, answer is therefore D. Question 17. Ethanol is produced by the fermentation of glucose from sugarcane. In some countries, ethanol is used as a fuel. Which statements are correct? 1. Sugarcane is a non-renewable or finite resource. As sugarcane is a crop, it can be grown again and again, so therefore it is not finite, it is renewable resource. Option 2. When sugarcane is growing, it removes CO2 from atmosphere. This is true statement because as sugarcane is a green plant crop, so therefore photosynthesis takes place, which removes carbon dioxide and produces oxygen gas. As only second statement is correct, so therefore answer is B. Question 18. Which changes will speed up a chemical reaction? First one is decreasing the pressure in a reaction between gases. Now this is incorrect because in gases the chemical reaction can be sped up if the molecules come close together, and that is only possible if the pressure is increased, not decreased. Second part is increasing the size of solid particles in a reaction involving solids. Again, this is incorrect because the speed of reaction depends on the particle size. So smaller the particle size, greater will be the surface area, so therefore faster will be the rate of reaction. The size should be decreased rather than increased. Part 3, increasing the temperature of any reaction. This is true statement because temperature increases the kinetic energy of the molecule, which in turn increase the successful collisions. Part 4, increasing the concentration of solution. This is also true for faster reaction because increasing the concentration increases the number of particles. So therefore, when particles increase, the chances of successful collisions also increase. Statement 3 and 4 are correct. Answer is C. Question 19. Magnesium reacts with dilute sulfuric acid. The reaction is given. Magnesium forms magnesium sulfate along with hydrogen gas. Two experiments are carried out at 25 degrees centigrade. The temperature is same for both. In first experiment, we have 24 grams of powdered magnesium. Again, in second, we have 24 grams of powdered magnesium reacted with 100 centimeter cube of 1 mole per decimeter cube sulfuric acid. And second one, we have 50 centimeter cube of 2 mole per decimeter cube sulfuric acid. During each experiment, the volume of hydrogen is measured. The results are plotted on a graph. Which graph is correct? We can see we have volume of hydrogen on y-axis and time on x-axis, and the graph shows the reaction rate. This is experiment 1, which shows straight line, and experiment 2 is shown by dotted line. As in the equation, we can see that 1 mole of magnesium interacts with 1 mole of sulfuric acid to form 1 mole of magnesium sulfate and 1 mole of hydrogen gas. As in both experiments, the mass of magnesium is same, so therefore number of moles of magnesium are same in both the experiment 1 and experiment 2. Let's find the number of moles of sulfuric acid in first experiment and in second experiment. We can use the formula. Number of moles is equal to concentration in mole per decimeter cube multiplied by volume in decimeter cube. Now volume is given in centimeter cube. This can be converted into decimeter cube by dividing by 1000. Similarly this one. So this one comes equal to 0.1 decimeter cube. And this one comes equal to 0.05 decimeter cube. Using formula, we can find the number of moles in first one. Number of moles is equal to concentration, which is 1, into volume, which is 0.1. So number of moles are 0.1 moles. In second one, we have concentration equals to 2, volume equals 0.05. So number of moles come equal to 0.1 moles. Now we can see that the number of moles of sulfuric acid are same in both experiment. So as number of moles of magnesium and sulfuric acid are same, the number of moles of hydrogen formed will also be same in both experiments. So from the graphs, we can see that in experiment 1 and 2, the number of moles are same, so volume is same. In part C, we can see that the volume is different, which is incorrect. Again, indeed, the volume given is different, which is wrong. Second thing is the steepness of reaction. Now the steepness depends on the rate of chemical reaction. This one represents slower rate and this one represents faster rate. Let's see which experiment is faster and which one is slower. In experiment 1, we have powdered magnesium. In experiment 2, we also have powdered magnesium, and concentration is same as the amount is same. But on dilute sulfuric acid side, we can see that the concentration is 1 mole per decimeter cube, while in second experiment the concentration is 2 moles per decimeter cube. Now rate of reaction does depend on the concentration. Higher the concentration, faster will be the rate of chemical reaction. So therefore the reaction rate will be faster in experiment 2 as compared to experiment 1. This shows experiment 2, so therefore this must be faster than experiment 1. It is not slower, therefore correct option is part A. Question 20. In which equations is the change in the underlying species correct? In first one we can see we have carbon. There are 4 hydrogen atoms present in this CH4, and then we have 2 oxygen atoms. So hydrogen is lost and oxygen is gained, so therefore this is oxidation. This is true. In second one we can see we have sulfur and hydrogen atom is present with sulfur and hydrogen is lost. So loss of hydrogen is also called oxidation, it is not reduction. Part 3 we have Br negative, which has converted into Br2, which is neutral. So from -1 to 0 it shows increase in oxidation state. So whenever there is increase in oxidation state, it is called oxidation, not reduction. As only one option is correct, answer is A. Question 21. The Haber's process converts nitrogen and hydrogen into ammonia. This is the reaction. Nitrogen gas reacts with 3 moles of hydrogen gas to form 2 moles of ammonia gas. Which row is correct? We have to find the change in condition and the position of equilibrium. First one is that pressure is increased. If pressure is increased, the position of equilibrium moves towards the left. Now when pressure is increased, the molecules come close together and more product is formed. This depends on the number of moles. We have 4 moles on the reactant side, 3 moles of hydrogen and 1 mole of nitrogen, and 2 moles on the product side. So therefore when pressure is increased, the reaction moves from more number of moles to less number of moles, which is moving towards the right. So this is wrong. Part B, pressure is reduced. When pressure is reduced, the reaction will move from less number of moles to more number of moles and the equilibrium will move to the left. This is also wrong. Part C, catalyst is present and due to catalyst, the equilibrium moves towards the right. This is incorrect because catalyst speeds up the reaction in both forward and backward directions simultaneously at the same rate. So we can say that due to the presence of catalyst, there is no change in the position of equilibrium. Only time required to achieve equilibrium reduces. Correct answer is therefore part D. Question 22. Which row shows the pH values for 0.1 mole per decimeter cube solutions of ammonia, hydrochloric acid, sodium chloride and sodium hydroxide? Ammonia is alkali as it can dissolve in water to form ammonium hydroxide. HCl is acid as it forms H positive ions and Cl negative ions. NaCl is neutral salt and sodium hydroxide is strong alkali. As compared to ammonia, it is stronger. So we can say that as NaCl is neutral, its pH will be 7. As 7 pH represents neutral. Alkali is strong, so therefore its pH should be 13, not 1. Acid is a strong acid. HCl is a strong acid, so therefore its pH will be nearer to the 0. It should be 1, not 11. And ammonia is an alkali, so therefore its pH should be 11. As it is less strong as compared to NaOH, so therefore it cannot be 13. Correct answer is part C. Question 23. The water in lake is acidic and fish are dying. The water in the lake needs to be neutralized. Which compound can be added in excess to neutralize the water in the lake. Part A, we have calcium carbonate. Now calcium carbonate can react with acid to form salt, water and carbon dioxide. So therefore this can be used to neutralize the acid, as acid is converted into salt and water. For example, if we have HCl, so it will be converted into calcium chloride salt along with H2O and CO2. So acidity will be reduced. Part A could be correct. Part B, we have phosphoric acid. As we already have acid in the lake, so therefore we cannot use another acid. This is incorrect. Part C is potassium hydroxide. Now potassium hydroxide is a strong alkali. It can be used to neutralize acid to form salt and water. But in the question they have said that which compound can be added in excess. So when strong alkali is added in excess to the acid, it will first neutralize all the acid that is present and then it will increase the pH as it is in excess. So therefore we cannot use this one. If calcium carbonate was added in excess, it does not increase or decrease the pH by itself. In part D, we have sodium nitrate. Again, sodium nitrate is a nitrate salt, NaNO3. This is neutral salt, so therefore it has no effect on the acid or acidity of the lake. Correct answer is therefore part A. Question 24. Two incomplete statements about the preparation of an insoluble salt are given. We have different options. We can use these to fill in these blanks. Which words correctly complete gaps 1 to 4? In the question they have given the preparation of insoluble salts, so you should remember that insoluble salt is prepared by precipitation method. In precipitation, two soluble solutions are taken. They are combined together to form desired insoluble salt. Which can be filtered out. So we can say that precipitation can be used to prepare insoluble salts, such as we know that all nitrates are soluble, so therefore it is not barium nitrate. Lead sulfate is insoluble, so it could be lead sulfate. The salt is collected by, we have evaporation or filtration. As this is insoluble salt, so we can use filtration so that it can be filtered out from the solution. And then it is washed and dried. Correct answer is part C. Question 25. The Haber's process is used to make ammonia at a temperature of 400 degrees centigrade and a pressure of 20,000 kilopascals. The temperature is changed to 500 degrees centigrade, but the pressure is kept the same. What will be the effect of this change on the production of ammonia? We can write the chemical equation. For ammonia, we have nitrogen, hydrogen, it forms ammonia. The reaction is exothermic as enthalpy change is negative. Part A, it is made at an increased rate and the position of equilibrium moves to the left. Now we have increase in temperature. Now increase in temperature will make the reaction faster. But as enthalpy change is negative, so therefore for exothermic reaction, increase in temperature makes the equilibrium move to the left side. So option A seems to be the correct one, as temperature will increase the rate and equilibrium will move to the back side. Part B, it is made at an increased rate and the position of equilibrium moves to the right. This is incorrect because the reaction is exothermic. Part C, it is made at a decreased rate. This is incorrect for increase in temperature, because temperature increases the kinetic energy, which increases the rate of chemical reaction. Correct answer is therefore part A. Question 26. Some properties which indicate the differences in elements are listed. We have metallic character, number of electron shells in an atom, number of protons in an atom, total number of electrons in an atom. Which two properties increase across a period of the periodic table? In periodic table, group 1, 2, and 3 consists of metals, while group 6, 7, and 8 consists of pure nonmetals. So therefore metallic character decreases along the period. So it does not increase. Second is the number of electron shells in an atom. As in a period, the number of electron shells are fixed. For example, in third period we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur. All these elements present in the third period of the periodic table have 3 shells. For example, the atomic number of sodium is 11. 2 electrons are present in first shell, 8 electrons are present in second shell, 1 electron is present in third shell. So we have 3 shells. For magnesium, the atomic number is 12. 2 electrons are present in first shell, then we have 8 electrons, and then we have 2 electrons. So again 3 shells are present. Number of shells remain constant. Third is the number of protons in an atom. In sodium we have 11 protons, then we have 12 in magnesium, 13 in aluminum, 14 in silicon, 15 in phosphorus, and so on. So therefore number of protons do increase across the period. 4 is the total number of electrons in an atom. Now as the number of protons increase, the number of electrons also increase, because in neutral elements the number of protons is equal to the number of electrons. Option 3 and 4 are correct. Answer is therefore D. Question 27. Elements X and Y combine to form an ionic compound. Atoms of X have more protons than atoms of Y. Atoms of Y have more valence electrons than atom of X. Which statement is correct? As element X and Y combine to form ionic compound, now ionic compound can be formed between metals and non-metals. Now metal can be from group 1, 2, 3 or transition. Non-metal can be from group 6, 7, which are non-metals. Now in metals, in group 1 we have 1 valence electron, in group 2 we have 2 valence electrons, similarly in group 3 we have 3 valence electrons. It says atoms of Y have more valence electrons than atom of X. It means Y is a non-metal, as it could be from group 6 or group 7, and X is a metal. Now second thing is that atoms of X have more protons than atoms of Y. It means X belongs to next period in the periodic table. For example, if Y is in period 2, so X must be in period 3. If Y is in period 3, X must be in period 4. Let's move towards the statements. Part A, ions of X are negatively charged. Now as X is a metal, metal loses electron to form positive ions. Part B, atoms of X have more electron shells than atoms of Y. As we have seen that X should be in next period as compared to Y, so therefore the period number represents the number of electron shells. For example, in third period we have 3 electron shells, in second period we have 2 electron shells. So therefore electron shells should be greater in X as compared to Y. This is true statement. Part C, X and Y are in the same period of the periodic table. This cannot be true because X have more protons than Y, so as Y is in the end of periodic table, X must be in the next line. Part D, X and Y are in the same group of the periodic table. This is also wrong because X is a metal and Y is a non-metal. And in same group, either metals are present or non-metals are present. Correct answer is therefore part B. Question 28. The elements in group 1 of the periodic table show trend in both their reactivities and their melting points. Rubidium is in group 1 of the periodic table. Which statement about rubidium is correct? Part A, it has higher melting point than potassium. In group 1 we have sodium, then we have potassium, then we have rubidium. So moving down in group 1, the metallic bond strength decreases, so therefore melting point also decreases. So the melting point of rubidium should be less than that of potassium. This is wrong. Part B, it reacts with water to produce an acidic solution. This is also incorrect because group 1 metal are called alkali metals because they form alkaline solutions. For example, rubidium will react with water to form rubidium hydroxide along with hydrogen gas. So the solution is alkaline, it is not acidic. Part C, it reacts with water to produce oxygen gas. This is incorrect because it forms hydrogen gas upon reaction with water. Part D, it is more reactive than potassium. This is true statement because reactivity increase down in group 1. This is because loss of electrons become easy as size of atom increases, so therefore the reactivity also increases. Correct answer is part D. Question 29. The properties of 4 substances are shown. Which substance is a metal? Part A, it conducts electricity when dissolved in water but not when solid. Now metal is a good conductor in solid form, so therefore this statement is wrong as it has free electrons present. Part B, it has high melting point and conducts heat when solid. This is true for metals because in metals metallic bonding is present and melting point is high as compared to non-metals, and due to metallic bonding they are good conductors of heat and electricity. Part C, it has low melting point and is brittle. This is incorrect because the melting point of metal is higher and it is not brittle, it is malleable. Part D, it has a giant covalent structure with high melting point. This is not true because in metals metallic bonding is present. So the structure is C of electron type, so therefore this is wrong. Answer is part B. Question 30. Group 1 elements and transition elements are metals. Student X suggests that group 1 elements are above hydrogen in the metal reactivity series but that not all transition elements are. Student Y suggests that the densities of group 1 elements are lower than those of transition element. Which student is correct? For first student we can see the reactivity series. We have potassium, then sodium, magnesium, then we have zinc, iron, lead, copper, silver. It says that group 1 elements are above hydrogen. Now hydrogen comes between lead and copper. And these are the group 1 elements. We have potassium, we have sodium. So these are above hydrogen. So student X is correct. For transition elements, we can see that we have zinc, iron, lead. These are transition elements, and not all transition elements are above hydrogen. This is also true because copper is transition and it is below hydrogen. So student X is correct. Now moving towards student Y, he suggests that the densities of group 1 are lower than those of transition elements. This is a true statement because group 1 elements, they float on water, while transition elements have higher densities and more weight. So both students are correct. Answer is A. Question 31. Tin is more reactive than lead but less reactive than iron. Which method would be most suitable for extracting tin from its ore? For extraction, we can look at the reactivity series. We have potassium, sodium, calcium, magnesium, then zinc, iron, lead. Now it says that tin is more reactive than lead but less reactive than iron, so therefore tin comes over here. Below lead we have copper and silver. Now the elements present below magnesium, they can be reduced by carbon from their ores, and the elements present above zinc, they can be reduced by electrolysis. As tin is below magnesium, so therefore it can be extracted by the help of carbon. Electrolysis is not needed. Heating alone, this is only true for silver oxide, which can be decomposed upon heating. Part C is heating with carbon, this is true, as tin is below carbon. Part D is reacting with hydrogen. This is wrong because the position of hydrogen comes between lead and copper. So elements below copper can be reduced by hydrogen. Correct answer is part C. Question 32. Attaching pieces of magnesium to underground iron pipes can protect the iron from corrosion. Which reaction protects the iron from corrosion? From the reactivity series, we can see that magnesium is more reactive than iron. In metals, more reactive means which can easily lose electrons, so magnesium will easily lose electrons as compared to iron. It will form magnesium plus 2 along with 2 electrons. So oxidation of metal will occur. Now we have oxidation in part B, which is the oxidation of iron. This will not occur until magnesium is present. As this is sacrificial protection, so as long as magnesium is present, iron will not be oxidized. Only magnesium will be oxidized and it will form magnesium plus 2 along with the loss of 2 electrons. So correct option is part D. Question 33. Which reaction takes place during the extraction of aluminum from aluminum oxide using carbon electrodes? In aluminum oxide, we have aluminum plus 3 ions present, oxygen minus 2 ions are present. Aluminum plus 3, they gain electrons to form aluminum metal, and oxygen -2 will lose electrons to form oxygen gas. As electrodes are made up of carbon, so what will happen that at higher temperature, those carbon electrodes will react with this oxygen that has been produced to form carbon dioxide. So first reaction is correct. Oxide ions convert into oxygen gas along with the loss of 4 electrons. Second reaction is also correct, as carbon electrodes react with this oxygen that is formed to form carbon dioxide. In third reaction, we can see that the charge on aluminum is +2, which is incorrect because aluminum charge is +3 and it will gain 3 electrons. As statement 1 and 2 are correct, answer is B. Question 34. Which statement about gases in the atmosphere is correct? Part A. Carbon monoxide, which is CO, is a pollutant which causes acid rain. This is incorrect because carbon monoxide does not dissolve in water. Part B. Catalytic converters reduce carbon monoxide to carbon dioxide. Now, carbon monoxide can be converted into carbon dioxide in catalytic converter. This is oxidation, it is not reduction. Part C. Methane in atmosphere depletes the ozone layer. Methane is a greenhouse gas, so therefore it increases the average temperature of the atmosphere. Part D. Photosynthesis add oxygen to the atmosphere. This is true because in photosynthesis carbon dioxide is removed and it is converted into oxygen in the presence of chlorophyll. Correct answer is part D. Question 35. How many moles of hydrogen chloride are formed when 1 mole of methane reacts with large excess of chlorine in sunlight? This is a free radical reaction in which hydrogen atoms from methane, they are replaced by chlorine atoms. The chlorine atom replaces hydrogen atom, and this hydrogen atom converts into HCl upon reaction with other chlorine. So now this hydrogen is replaced by this chlorine and HCl is formed as the product. When chlorine is in excess, then all hydrogen atoms will be converted into chlorine atoms. So for that we can write the chemical equation. We have CH4, methane, chlorine, all hydrogen replaced by chlorine, so it will form CCl4 along with HCl. Now we can balance this equation. We have 4 hydrogens, so we can write 4 with HCl. Now we have 8 chlorine on the product side, so we can write 4 with Cl2. From balanced equation we can see that 1 mole of CH4, it reacts with excess chlorine to form 4 moles of HCl. Correct answer is 4 moles. Question 36. Compound X is shown in the dot and cross diagram. This is compound X. Which statement about compound X is correct? Part A, it is a saturated hydrocarbon. Now saturated hydrocarbon means that all carbon-carbon bonds must be single bonds. In this one we can see that between these two carbon atoms there are 2 pairs of electrons present. So therefore it means that it is double bond between these 2 carbon atoms. So therefore it is not saturated, it is unsaturated. Part B, it is an isomer of butene. Isomer means having same formula but different structure. In butene we have 4 carbon atoms as it is but, and ene means it is alkene. So for alkene the general formula is CnH2n, so hydrogen will be 8. In this compound we can see we have 3 carbon atoms and 6 hydrogen atoms. So therefore this is propene, not butene. B is wrong. Part C, it will decolorize bromine water. This is true because all alkenes, they can react with bromine and double bond is converted into single bond. Bromine atom is attached to the carbon making double bonds. So when bromine gets reacted, its color becomes decolorized. Part D, its name is propane as the formula is C3H6, so it is propene, not propane. Correct option is part C. Question 37, which statements about alcohols are correct? 1. All alcohols contain the hydroxide ion OH negative. This is incorrect because OH negative is present in alkalis, for example NaOH, which dissolves to form Na positive and OH negative. Alcohols do not dissociate to form hydroxide ions. Part 2. Ethanol can be formed from ethene using a reaction catalyzed by yeast. Now ethene can be reacted with steam in the presence of phosphoric acid at 300 degrees centigrade and 660 atmosphere pressure to form ethanol. No yeast is used, so therefore this is wrong. Part 3. Methanol can be oxidized to methanoic acid. Methanol is an alcohol containing 1 carbon atom. Methanoic acid is carboxylic acid consisting of 1 carbon atom. So as alcohol can be oxidized, we can write this CH3OH. This is 1 carbon alcohol which is methanol. It can be oxidized in the presence of potassium dichromate along with heat to form methanoic acid, which is HCOOH along with water. So this is a true statement. Part 4. The alcohols X and Y shown are isomers. Isomers means having same formula but different structures. In first one we can see we have 4 carbon atoms, so it is C4. We have 10 hydrogen atoms, 1 oxygen atom, and OH is connected with second carbon. In Y we can see we have 4 carbon atoms, 10 hydrogen atoms, 1 oxygen atom, and in this one OH is connected with the first carbon atom. So as we can see that the formula is same, structures are different, so therefore this one is also true. Correct answer is part D. Question 38. An ester has the formula C2H5COO C2H5. Which pair of compounds would react together to form this ester? Let's first draw the structure of this ester. We have 2 carbon atoms. Then we have C double bond O, then oxygen. Then again we have 2 carbon atoms and 5 hydrogen atoms. Now in the formation of ester, the portion containing carbonyl carbon, this comes from carboxylic acid. while the other portion comes from alcohol. So we must have 3-carbon carboxylic acid as the reactant, and 2-carbon atom alcohol as other reactant. 3-carbon carboxylic acid is called propanoic acid, and 2-carbon alcohol is called ethanol. Therefore, answer is part B. Question 39. Which statement about polymers is correct? Part A. Nylon and terylene are both polyesters. Now this is incorrect because in nylon we have amide linkage. So therefore nylon is polyamide. While for terylene, this statement is correct because in terylene we have ester linkage. So terylene is polyester. Part B. Proteins and nylon have the same monomer units. Now proteins are made up of amino acids. While nylon can be formed from 1,6-diaminohexane and hexane dioic acid. So monomers are different for proteins and nylon. This is incorrect. Part C. Proteins have the same amide linkages as nylon. This is true statement because in proteins we have amide linkage C double bond O NH. In nylon we also have amide linkage C double bond O NH. Part D. Terylene and fats are esters but with different linkages. In terylene we have ester linkage. In fats we also have ester linkages. So as the linkage is same, so therefore this statement is wrong. Correct answer is part C. Question 40. X is a polymer. When X is hydrolyzed, one of the product is substance Y. This is substance Y. Which type of polymer is Y? In Y we have carboxylic acid, we have NH2 amine group, we have alkyl group, we also have hydrogen. So this shows the structure of amino acid. And amino acids come together to form proteins. Carboxylic acid of one amino acid combines with NH2 of the other amino acid like this. This is carboxylic acid from one amino acid. This is NH2 from other amino acid. And they combine together to lose water and form amide linkage. So this is condensation polymerization, it is not addition. B is also incorrect because in fats ester linkage is present, while in this one we have amide linkage. It is also not a complex carbohydrate because in this one we have oxygen bridge. Correct answer is therefore part C.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.